You're walking to your car at night. The lot is empty. No one is there. But the hair on your arm stands up anyway. You glance over your shoulder. Nothing. You walk a little faster. Your heart is pounding for a threat you cannot name. You tell yourself you're being paranoid. But what if you're not imagining a threat? What if you're remembering one? That feeling isn't random. It isn't a glitch. It's a signal, fired by a part of your brain that is far older than your car, your parking lot, or your city. And the real answer is far stranger than paranoia. Your brain still thinks you're being hunted, not metaphorically, not as a figure of speech. Somewhere inside your skull, a small almond-shaped structure is still running software built for a world where something with teeth was often nearby. That structure is called the amygdala. It doesn't know what a car is. It doesn't know what a parking lot is. It only knows one thing. Danger might be close. Act now, think later. For most of human history, that instruction kept you alive. Go back 200,000 years. You are not at the top of the food chain. You are somewhere in the middle of it. Leopards drag human ancestors into trees at night. Crocodiles wait at the water's edge. Snakes hide in the grass you walk through every single day. You are not the apex predator of your world. You are, quite often, the prey. The anthropologist Lynn Isbell has spent decades studying why primates, including humans, have such unusually sharp vision compared to other mammals. Her research points to a specific and unsettling answer. Snakes. For tens of millions of years, snakes have been hunting the ancestors of primates, and primates have been evolving better and faster ways to spot them first. Isbell's snake detection theory suggests this ancient arms race helped shape the very structure of primate eyesight, tuning it to notice shapes like coils and patterns in leaf litter before the conscious mind even registers what it's seeing. Think about that for a moment. Part of the reason you can see this clearly is because your ancestors who couldn't see it clearly got eaten. Why does this matter now when there are no leopards in your parking lot? Because evolution does not delete old software. It builds new software on top of the old. Your modern brain, the one that pays bills and reads maps and remembers passwords, sits directly on top of an ancient alarm system that was never designed to be turned off. It was designed to be loud. It was designed to react before you had time to think, because the ancestors who stopped to think first were, quite often, the ones who did not survive to pass on that hesitation. The psychiatrist Randolph Nesse calls this the smoke detector principle. A smoke detector is not built to be accurate. It is built to be cheap to trigger and expensive to ignore. It would rather go off 100 times for burnt toast than miss one real fire. Your fear response works the same way. It is not optimized for truth. It is optimized for survival, and survival means false alarms are a small price to pay compared to the cost of missing a real threat. That's why you still flinch at a shadow shaped like a shape. That's why a rustle in dark bushes makes your pulse spike before your rational mind even catches up. Your body isn't waiting for proof. It's already moving. There's a reason certain fears feel almost impossible to reason your way out of. The psychologist Arne Oman ran a series of experiments showing people images of snakes, spiders, flowers, and mushrooms, then measuring how quickly their brains detected each one in a cluttered scene. Over and over, people spotted the snakes and spiders faster, and their bodies reacted to them faster, even when the images were flashed too quickly for conscious recognition. Oman's research suggested something remarkable. Certain fears aren't learned the way you learn a phone number. They're pre-wired, primed by millions of years of ancestors who needed to react to exactly these shapes before conscious thought had time to catch up. You were never taught to fear a snake-like shape in the grass. You inherited that fear, the way you inherited the shape of your hands. But here's where it gets stranger. That ancient threat detection system doesn't know the difference between a real predator and a modern stand-in for one. The neuroscientist Joseph Ledoux spent much of his career mapping exactly how fear moves through the brain, and he found something important. Sensory information doesn't just travel to the thinking parts of your brain first. It also takes a faster, cruder shortcut straight to the amygdala. Ledoux called this the low road. It's quick, it's sloppy, and it reacts before your conscious mind has even finished processing what it saw. That's why you can jump at a coiled garden hose before you consciously register that it isn't a snake at all. The ancient alarm fires first. The correction comes later, if it comes at all. Now look at your life today. You don't walk past leopards, but you do walk past strangers on dark streets, and something in you still runs the same threat calculation your ancestors ran. You don't hear predators rustling in tall grass, but you do hear notifications, and something in you still checks, again and again, as if survival depends on it. You don't need to scan the horizon for smoke from an unknown fire, but you scroll the news anyway, absorbing story after story of danger you cannot control, because some ancient part of you still believes that information about threats is the same thing as safety from them. Ever notice how easy it is to get hooked on true crime? On horror movies? On doom scrolling at midnight when you know it won't help you sleep? That's not a personal failing. That's an ancient survival circuit, still running, still asking the same question it has asked for hundreds of thousands of years. Where is the danger, and how do I see it before it sees me? Modern life removed almost every real predator you'll ever encounter. It didn't remove the part of you built to expect one. This is why an empty parking lot can feel loud with danger that isn't there. This is why a closed door at night can make your imagination sprint ahead of the facts. This is why, even in the safest era humans have ever lived in, so many people still describe a background hum of unease they can't quite explain. You're not broken. You're not weak. You're running an alarm system built for a world that mostly no longer exists, and it hasn't gotten the memo. Understanding this doesn't shut the alarm off. It was never designed to be shut off, but it can change how you listen to it. The next time your pulse spikes at a shadow, the next time you check the back seat before pulling out of a driveway, the next time a dark hallway makes you move a little faster than you need to, you can recognize what's actually happening. You're not overreacting to now. You're reacting appropriately to then. You're walking to your car at night. The lot is empty. No one is there. But the hair on your arm stands up anyway. And this time, you know exactly why. Your brain isn't malfunctioning. It's remembering. It's still doing the one job it was built to do best, keeping something that used to hunt you from ever catching up again.